So welcome everyone. This is our stereochemistry course. This is lecture 10, and in the previous lecture we are talking about that the unusual chiral compound, basically where there is a no chiral center present, but there is a chiral axis present. And with this we are talking about axial chirality, planar chirality, helical chirality, heteroisomerism, and cubic system. So if you have directly come to this particular video, then I highly suggest to watch the previous video to understand what is the chiral axis or what is the axial chirality actually is. And today in this particular video, we are talking about that how do we RS nomenclature of the chiral axis compound. And in this video, I'll show a trick basically that actually I used frequently for determining the RS nomenclature for the chiral axis compound. And I hope this particular trick will also help you in your exams. Okay. So please very cautiously watch this particular lecture. Okay. So first of all, how to determine the RS nomenclature of chiral axis compound. So basically, this type of compound you are actually observed in the kind of axial chirality where the chiral axis is nothing but this, where this two particular group present in the in plane and this two particular group present in the out of plane system, where the CH3 is towards the observer and the H is the below the plane of paper, or we can say the away from the observer. Okay. So first of all, in all the case of RS nomenclature, we have to first determining the priority order. Okay. So in kinds of normal chiral center, what we have do, we have to priority assign of the all the groups present in the chiral center associated with chiral center. But here the priority order was assigned based on each carbon center. Like for this particular carbon center, between these two groups, we have to determine the priority. Similarly, for this carbon center also, we have to determine the priority between these two. Okay, so this will be the first step for determining the RS nomenclature. After that, what we have done is the trick is actually going from here. So then what happened that this particular molecule, we have to rotate this molecule such a way, okay, such a way that planar group, this two actually the planar group here, so it should be present in downwards. Like in earlier case, you will observe that here this particular group, if we want to rotate this overall molecule to make this two are planar, then we have to rotate it something like this type of way. So this will be rotated and looks like this particular way, so that these two planar group are now in the should be present downwards and the out of plane group should be present upwards. Okay, now our viewing from this particular side, we view the molecule from this end. Okay, now interesting thing is here these two we can take as a horizontal bond of Fisher projection. Like we already know, we already discussed about that horizontal bond and vertical bond Fisher projection. So these two particular group now be present in the horizontal bond of Fisher projection. Okay, this planar group now present. And how to determine the position? Like as simple, like since this particular group present in the left side of our viewing, okay, so this group present in the left, and since this priority is 1, then this priority group 1 present in the left side of the horizontal bond, and this particular hydrogen present in the right side of our viewing angle. So this particular hydrogen present in the right side and its priority is 2. Now we have to determine the vertical bond group. So obviously, since this particular two groups are present in the horizontal bond, that means vertical group should present these two groups. Okay. Now there is a trick that whatever this particular group present in the wedge dashed bond, that is the below the plane or away from the observer bond, whatever group it should be present, it should present in the downward position. That keep the dash bond down in vertical bond in Fisher projection. That means this particular group that is away from the observer, it should present the below of the vertical bond. Okay. Now how to determine the priority? Like in horizontal bond, it will be prioritized as 1 and 2 as here. Now in this particular carbon, although this particular group CH3 is the higher priority order according to CIP rule, so it should be 1, but it is a pseudo 3 group here. Okay, like this, the groups which are present out of plane, they are actually determined as pseudo 3 or pseudo 4 group. Okay, so this, since this particular hydrogen present in the away from the observer bond, that is the dash bond, and it is the priority is 2, that means pseudo 4, so it should be present in the downwards. And this particular group, there is a wedge bond group, this having the priority of 1, it is in terms of this particular carbon, so it will present in the vertical up. Now if we see the rotation, then 1 to 2 to 3 is the anti-clockwise rotation. Okay, now the rule is if 1 to 2 to 3, 1 to 2 1, that is a pseudo 3, it is a clockwise, then R, and if 1 to 2 to pseudo 3, it is anti-clockwise, then the configuration is S. So our in this particular compound, we have seen that the rotation is anti-clockwise in nature. So this our compound is S, and the A suffix is signifies that the molecule, the nomenclature or absolute configuration of this particular molecule, it is determined by axial chirality method. Now this A or the suffix will be optional, like not necessary, you have to give. Now same rule to determine axial chirality will be applied for spiro compound and biphenyls. Same rule that we use for the axial chirality we use for spiro compound and biphenyls. Like here in this particular compound, it is a very interesting compound. Like here you can say that this is not a chiral axis compound, it is a chiral center, it is observed. Okay, but it is actually not a chiral center. Why? Because we already know that chiral center can be occupied by 4 different groups. But here you can see this group and this group are similar, and also this group and this group are similar. So this is not a chiral center. We can view this particular compound as a chiral axis. Okay, and to determine the RS nomenclature, we are actually going for the similar pathway. Like our viewing angle is here, and the horizontal and the particular group that is plain in the paper that present downwards and our viewer. So this particular group present in here, so it will horizontal bond, it will present like here, and the oxygen, between oxygen and carbon, oxygen have the higher priority order, so it will be prioritized as 1, and this particular group present in the right hand side, since our viewing observation, okay, our viewing, this is present in the right side and this is present in the left side. Here I want to tell you the very cautious thing, that always try to keep the out of plane bonds above and the plane of the paper bond below while viewing the particular molecules. It will be very crucial, otherwise your absolute configuration might get changed. Okay, so what happened that here 1 and 2 are determined, and simple that already we know that dashed bond present in the lower side of the vertical bond, so it will be lower, and since this particular group has the highest priority, so it present in here, that is 1, that is nothing but a pseudo 3, and this particular 2 group, that is the pseudo 4 is here, so the rotation 1 to 3 is clockwise, so it will be R. Similarly, this is a biphenyl system. Already know that biphenyl system plane not present as a plane of paper, both of the ring, because of the steric issues. So we have simply rotate this particular molecule such a way that this 2 group that is plane in the paper, okay, will present here. Okay, so between OH and H, OH will be the highest priority and it present in the left side. So in horizontal bond, it will present in the left side itself, and the hydrogen is the priority order 2 and present in the right side of the our viewing line. This is our viewing line. Okay, this is our viewing line. So it will present here. Now the dashed bond group will always present in the lower side of the vertical bond. So it will be present here, and the final group will be present here. Now 1, 2, 3 is a clockwise rotation. So the configuration of this particular absolute configuration is R, and A will be uh, a subscript, and it can be used, or it is optional. You can use or you cannot use it, depend up to you or up to the question paper, that how the MCQ is there. It is only written R, then it is okay. If RA, it's also be there. So I hope that this particular is clear for you. And so with this, we have to end this particular RS nomenclature. And in the next class, we are talking about the topicity of organic compound. This is another important topic, especially for the exam purpose. Like in every year, one question from the topicity is there. And in the previous, whatever discussed, you just practice with some other questions and just follow the rules given in there. I hope there will be no issues, and we will again revise this particular rule when we are dealing with some kind of questionnaires. Okay, so that's all for this particular lecture. We'll meet on next lecture with topicity. So thank you for listening.